Okay, so today what we're going to be talking about is comparing expressions. Or at least that's going to be the first thing we're going to talk about today. So in chapter 1, we focused on writing expressions and describing the relationships between them. However, now what we're going to do, we can start comparing them in different situations. So let's try doing an example to start. Let's try. Well, first of all, you know that there's these different symbols that go along with these kinds of expressions, and here are the ones that I can think of right now that are important for you. So if you were to take a closer look at this, this one over here is less than. This one is greater than. This one you should definitely know. This one's equal, or equal to, equal. This one is less than or equal to, and this one's greater than or equal to. So these expressions are important as a means of comparing different numbers and expressions. So that being said, let's try to evaluate something. Let's just try. So what if we had negative 2x plus 4 and x plus 6, and we know that the value, and we know that x equals 5. Let's use that value. So what you need to do is you need to substitute these values, and you need to substitute all the x's for 5s, and then compare them once it's combined to a single number. So negative 2 times 5 is 10 plus 4 equal to is blank 11. Negative 10 plus 4 is negative 6. Then 11. So based off of that, you should know that negative 6 is less than 11. And this will be your answer. This would be your answer. So now you should know how to solve these kinds of problems. But what if we have a more general kind? Let's say we have x. We have 2x. Pushing out a little bit. We have 2x and 3x. Funky. So here's something interesting about these. If you don't need to have any certain evaluation and know which one's great, if it's value, here's what we can do. Now, you know that if most people would just look at the coefficient and say, oh, 2x is greater than 3x. Okay, that's a fair assumption. However, it's not always greater than less than, because you have to also consider that negative numbers can be replaced for x. Like if we had x equals negative 4, what would happen is 2 times negative 4 is negative 8, and 3 times negative 4 is negative 12, and negative 8 is greater than negative 12. It's not less than. That'd be incorrect. It's not less than. So what we can say with this, actually, we can actually it can also be equal to, because if x equals 0, 2 times 0 is 0, and 3 times 0 is 0 3 times. So and that's equal, and they're equal to each other. So for this kind of general expression, the answer would have to be this is how you write it. It's a little different. You need a special symbol for this situation. So it could be written like this. You can write it as greater than, less than, or equal to. So that's kind of a way of writing it. So that would be what you need to put for a kind of general expression. However, there are some general expressions that are not always all three types of a comparison. Not all. What if we had x plus 2 and x plus 4? Now in this case, it's glitching out a little bit. in this case, you're gonna have this is gonna always be less than this always, because if no matter what value x is, no matter what, so like it could be -3 or something, or -415 million, it's always going to be large. And x plus 4 is always going to be larger than x plus 2 is always going to, because you can't, like for example, you can't say that if we had x equals 3, then that would be 5, and that would be that would be 7. So it's never going to be, and if it's x plus 4, it's always going to be larger by at least 2. It's always, no matter what, because we're not multiplying by anything. So a useful trick in knowing these general comparisons would be to know if there's multiplication involved, then you might need to double check. Because multiplication, and when you get the negative numbers in the mix, it might get a little different, I guess. So, and it goes for the same for division. Also, goes for the same for division. If it has to have multiplication or division, then your best bet would be to assume that in most situations it'd be greater than, less than, equal to. However, it's not. I'm gonna put most just for reference, because it's not always going to be that. It's not most of the time. Most of the time it will be. However, you can come across different kinds of situations and scenarios that would make it different. And if it just involves addition, I'm just going to do shorthand. If it involves addition and subtraction, if you just have a single variable, and let me say this is multiplication or division, negative numbers, and if it involves multiplication or division with a positive number, then it's mostly safe to assume that it's only going to be just one of them, just one. So you can experiment with this yourself and see how these different rules come into play. But you should always try substituting values beforehand before you make a complete assumption. So with all that out of the way, these expression comparisons, we can start doing something a little more interesting. And that today I'm going to introduce solving one-step equations. Now, you might have come across this earlier in your studies of pre-algebra. However, you've never really talked about this in arithmetic. You've never really and lucky for you, it's not actually incredibly complicated. It's not incredibly lucky for. So it's not. What you need to know about equations is that, well, you need to know what the job of an equation is, like what it's intended to do. So, and you have to know that an equation finds the value of a variable in an equation. So it finds an unknown value that you might not know at the beginning. Okay? And you can solve equations with multiple variables in them if you have a system that's a little more complicated, so we're not going to get into that until a while. Maybe that should be something you should take down in your notes. That an equation finds the value of a variable, okay? And if it would have to have some sort of algebraic expression involved on one side at least. And you know that the unknown value or the variable can be solved, and you know how the procedure for doing it. So here, let's start with our first example. Let's start there. Let's say we have x plus 2 equals 5. So what we want to know is we want to know the value of x. This is what we want to figure out. We already know that 2 equals 2 and 5 equals 5, so it'd be kind of dumb to just solve for that. It'd be kind of dumb. So here we need to find the value of x. This is what we want to know. So you got to know the different steps that are necessary to solve for x. Now, maybe from your intuition or using some logical reasoning, you would know that x would equal 3 because 3 plus 2 equals 5, and nothing else would nothing else plus 2 would equal 5, because it just wouldn't make sense. And that is true, and that would make sense because x would have to equal 3 for this to make sense. But how do we know that exactly? And so this is how we do it. How do we know? This is the algebraic way to solve the equation. So in algebra, a thing we do very often is we need to perform the opposite operation to a constant value now to get some sort of result. So let's take a look at pop up 2. In fact, this is positive 2 to be more precise. This is so if this is positive 2, what we can do to get x alone on this side would be to subtract 2 to both sides. And just so we're clear here, a side of the expression, each side is on the opposite ends of the equal sign, or on the opposite end. So just so you know, because you can't have you can't get your sides mixed up when it comes to equations. You can get your sides. So we have but okay, so we did the -2, but we also need to do it on the opposite side. So let's do it like that. You need to put -2 on the 5, or else it also won't be balanced, and you would get an unreasonable answer. You know? So what happens here is that, let's look at this part first. Let's look at this. So we know that 2 minus 2 equals 0. But we don't need to put 0 below our summation bar. We don't need, because since 2 minus 2 is 0, it's not going to impact the answer in any way. Because if we drop this down to x plus 0, x plus 0 just equals x, because anything plus 0 is the number itself, isn't it? So we don't need to put 0. That would be redundant. So what we can do very simply is cancel out the 2 minus 2 by just putting a slash on it. So that means we know we don't have to deal with it anymore. We don't have to. So now all we're left with here is x on this side. So we're gonna drop that down. And then since we have an equal sign here, drop the equal sign. You always need to drop the equal sign. And then whatever 5 minus 2 equals, and 5 minus 2 is 3, and I really hope you know that. So, and that gives us our answer to our equation. It gives us which is x equals 3x equals. So that's the more algebraic way of solving the equations. More algebraic. Let's try another example. Let's say we have x minus 4 equals -6. So what I want to do is what we want to do is to figure out the algebraic way of solving this, not just using your intuition. So the first step here is look at the constant that is accompanied by the variable. So this is -4. This is not +4 this time. So what we need to do, or maybe if it helps you, you could what you can do first is put borders between the signs. It's just for reference, so it helps you. You should eventually be able to not see the provision of having to put these borders on here. But if it helps you, then by all means you could go ahead and do it. So what we would do here, since this is a -4, we need to do that. We need to perform the opposite operation, and I will, just so you know, I'm just going to put in capital letters in here because it's important. It's just really important. You know how you know that that's part of the procedure. Or sorry, it's not. They say opposite operation, and I meant to say it was the opposites sign, opposite sign, because you know that if we have a positive number and then we take the negative or the opposite of that number, then what we know is that they're going to equal 0. That's the whole point. We need to make it equal to 0 because it's not, and also it wouldn't make sense in any other way, because you're just giving yourself more steps if you don't make them cancel out to 0. So -4, we can put +4 right here, because -4 plus 4 would equal 0, which is the same thing as 4 minus 4. So we want to cancel them out so that they equal 0. So +4 gets put on this side, then +4 is put on the opposite side as well. So we put our summation bar. The only point that we put a summation bar, because it also is going to look like it's an unending equation of different slews of numbers, and it would just be disorganized. So we know that -4 plus 4 is 0, so we can just cancel those out. We could put a solid sign around it, and then since all we're left on this side is x, what we can do, we can just drop the x down here, and then drop the equal sign down, and then what we're left with here is -6 plus 4. -6 plus 4 is -2. If it helps you think about it the other way, 6 minus 4 is 2, but since it's negative, you just add the minus sign. So x equals -2 in this situation. X equals, and that would be our answer, or what was formerly called the solution. As you'll see eventually when we start graphing equations that are linear, linear equations, you'll start to understand why we have such elaborate formats for our numbers and procedures and stuff. So one last thing I want to talk about is how we can double check if our answers are correct. Well, very simply, just replace whatever x is, just evaluate like 3 plus 2 equals 5, and we know that's true because if you were in kindergarten a long time ago, you should have known that since the beginning. And since x equals -2, we can just replace -2 for x in the original equation. And we know that -2 minus 4 is -6, because 2 plus 4 equals 6. We just use the opposite sign, and it would be -6. If it helps you to think of it that way. So you just have to be careful with the signs, though. And in conclusion, you always need to remember that it's the opposite operations, so that they can cancel out to 0. Or else you're just gonna give yourself a hard time.